I can write and use linear inequalities to model and solve real-world problems. Here's what you need to know. A constraint is a necessary condition in a word problem. Constraints are often written as inequalities. A set of constraints, therefore, forms a system of inequalities because we have more than one at a time. The graph of your solutions to the system of inequalities is something called the feasible region. And if you know what the word feasible means, it means possible. So we're shading the possible solutions to the word problem. The feasible region contains every possible solution to the problem. So in this example, on my graph, I have this gray shaded region. That shaded region is called the feasible region. Let's take a look at an example. You're making a snack mix consisting of granola and peanuts. Granola has 3 grams of fiber per ounce, and peanuts have 2 grams of fiber per ounce. You want your snack mix to have at least 16 grams of fiber and weigh no more than 8 ounces. Write the constraints that model this problem. So again, constraint means like the limitations on your variables. You're saying what you can and cannot be. Let's start by identifying our variables. Let X represent the ounces of granola, Y represent the ounces of peanuts, and now we can use this information in the problem to write a system of inequalities. We want our mix to contain granola and peanuts. That means we're going to have some amount of ounces of each ingredient. My amount of granola is going to be greater than 0 ounces, and my amount of peanuts is also going to be greater than 0 ounces. These are constraints. We also know that granola has 3 grams of fiber per ounce, peanuts have 2 grams of fiber per ounce, and we want at least 16 grams of fiber. That means that I want exactly 16 or more than 16 grams of fiber. So my combined fiber from my granola and my peanuts needs to exceed 16, or it could be exactly equal to 16. We want our snack mix to weigh no more than 8 ounces. So my combined ounces of granola and peanuts needs to be no more than 8. That means I can be less than 8, preferably, but I could also be exactly equal to 8. I just can't go over that value. So right here, we've got 1, 2, 3, 4 different constraints that we've written. There are inequalities. And if we go ahead and plot them on the coordinate plane, we get something that looks like this. Now notice that this is just quadrant 1 because of our first set of constraints. X has to be positive and Y also has to be positive. So we're not showing the part of the graph that would be over here or down here or over here. This is just quadrant 1. And then we have our 2 lines. We have x plus 8 less than or equal to 8. I'm sorry, x plus y less than or equal to 8. And we have our other inequality, 3x plus 2y is greater than or equal to 16. We're going to shade the region that works for each inequality. So my green area is called the feasible region. If a point is in the feasible region, any point that's in this green section, that means that it will be a solution to my system of inequalities. Let's test out some possibilities. So the point 4, 3. I'm going to come over to 4 and then up to 3. That is inside my green region. If I plug in 4 and 3, I could have 4 ounces of granola, 3 ounces of peanuts, and that would fulfill my requirements. I could also have 5, which should be right here, and 2, 5 ounces of granola, 2 ounces of peanuts. So any point that's within this green section is a solution to your system. Go ahead and pause and try this one. Aaliyah needs to bring at least 25 pieces of fruit to a training practice. She suggested apples and oranges and was told to be sure to bring more than 10 apples. Let X represent the number of apples and Y represent the number of oranges. Which inequalities, plural, model the situation? So you can choose more than one answer. Let's test out choice A. We're saying X is apples and Y is oranges. I want to know if apples plus oranges has to be greater than 25. That's not quite correct. We know that the total pieces of fruit, this says that it's more than 25, but my word problem told me that she needs at least 25. That indicates I could include the value 25. I don't have to just be bigger than 25. That leads us to choice B being correct. The total number of pieces of fruit is at least 25. This inequality symbol correctly represents our situation. Let's test out C. X, which would be apples, needs to be greater than 10. Yes, that does fit the problem. The number of apples does need to be more than 10. That helps us eliminate choice D. The number of apples cannot be equal to 10. She needs to bring more than 10. She can't bring exactly 10. So this inequality is out. We can't use that symbol. Choice E says Y, which would be our oranges, has to be greater than 0. Yeah, that's true. We're told that she's bringing apples and oranges. If she's bringing oranges, that means that she has to have more than 0 oranges. And let's test F. Let's see if Y, the number of oranges, could be greater than or equal to 0. That's not true because we know she's bringing oranges with her. She cannot bring exactly 0. This inequality symbol would not fit our situation. If you want more on this topic, be sure to check out the Learning Target spreadsheet for additional resources, videos, and practice.